Okay, so I like to start you off with the harder questions. So number one's usually the most pain in the back. Alright, yes it is. Mr. McLean's got 4 3/5 pounds of flour in a container. He's also got a box with 1.5 pounds of flour. If he pours 1/4 of the flour from the box into the container, how many ounces will be left in the box? There's a whole lot of stuff going on here. So we can draw ourselves the container. That's got 4 in. If we don't want to use fractions, how can we write 3/5? That's 0.6. We should know our fifths. Okay, 0.2, 0.4, 0.6, 0.8. He also has a box, so we can draw a little box here, and it's got 1.5 pounds. Says he's going to pour 1/4 of flour from the box into the container. So we're going from the box into the container, but are we pouring all of it in there? No, just a fourth. So how can we find 1/4 of a number? We divide it by 4. So we figure out what is 1.5 divided by 4. So 4 goes into 1. 0 times it goes into 15. 3 times. So this is 12. 4 goes into 30. 7 times. And then we get 5. It's 0.375. That number should also look a little bit familiar to you. If not, that's okay. So this is leaving the box, going to the container. So what's going to happen to our amount in the container? It's going to go up. What's going to happen to the amount in the box? Or down. We could add this, but really what's the question asking us about? It's asking about just the box. So do we really care what got added to the container? No. So we're just going to worry about subtracting from 1.5. So we have our original 1.5 minus what we took out. Don't forget to line up your decimals. You can add a couple zeros here so we don't make terrible subtraction errors. We regroup. So we borrow from the 5 and we get 10 here. Why do we do that? Because we're going to borrow again to get to the ones place. So 10 minus 5, 9 minus 7, 2, 4 minus 3. Okay, good job. And 1 minus 0, 1. Like if, yes. Okay, so we have 1.125. What unit is this still in? Pounds. So we have 1.125 ohms.
Why did you need to take away from 5?
This one? Because we needed something in the tens place so we could borrow from the tens place to have something for the ones place. Okay? So how can we go from pounds to ounces? Is it divide? If we said, how many ounces are in 2 pounds?
Divide. 16 times.
You would say 16 times 2 is 32. So we're not dividing by 16, we are multiplying by 16. So our last step is say, what is 1.125 times 16? And this is where a good knowledge of fractions and decimals would have helped out a lot.
How do you, like, if you don't know the fraction, how do you get it?
You divide it, like 3/5. We can write as 3 divided by 5.
You always put the smaller number in.
No.
I mean the numerator.
Yes, top in, bottom out. Okay. So this should work out to a nice whole number.
That's 30. And then that's 32.
This is 0, 15, 7, 6, 0, 5, 2, 2. No, not 2. Ha ha ha, JK. So we get 0, 0, 0, 8, 1. How many decimal places? 3. So 1.125 pounds is 18 ounces. It's not 10. Good thing you added it yourself, and so you weren't just waiting for me to tell you what the answer was. Okay. The reason why I keep talking about fractions, anyone off the top of their head know what 0.125 is as a fraction?
Yes. That would be 59,125. That's basically 25 cents. That's a quarter.
No, 25 cents is basically a quarter. 0.125 is 1 over, somebody's going to say it eventually, 8. So, how many ounces is 1/8 of a pound? How much would each of these slices represent? How many ounces?
1/8.
If it's 16 ounces for the whole thing, 1/8 of it would be 2. So 1 pound is 16 ounces, an eighth of a pound is 2 ounces, 16 plus 2 is 18. So if you knew that, you could have saved yourself some calculations. Since we don't know that, we have to stick with calculating. Okay? No, you can't use a calculator on the test. No matter how many times you ask, you can't. Okay, number 2. Two rectangles are similar. Large one has a length 5.4 and a width 3. Smaller one has a width 1.5. What is the smaller rectangle's length? This is kind of confusing because there's decimals and a lot of words. So the easiest way to solve this would be to do what? To draw what? A picture of 2 rectangles. So it says large one is 5 by 4 by 3. And it says the width on the other one is 1.5. We need to make sure that width goes with width. So this is 1.5. We're looking for the length. So a couple ways we could figure this out. We could make a proportion. We could call this big. Okay, that's kind of boring, but whatever. And Robbie. So we pick one side from the big rectangle. 5.4, thank you. What does that correspond to on Robbie? X. And then 3. Okay, and we can cross multiply that.
3x. Could we? 5.4.
On your paper, you could do that.
How come we couldn't just divide by 2?
That's the other way.
Seems like a much easier way.
So that'll give us 8.1.
Sure.
And then what can we do with that number?
Divide it by 3.
We can divide it by 3
Where'd you get the 3 from?
because it's the number we didn't just multiply.
I mean 2.7.
This will give us 2. Whoops. 2.7. Okay, so that's one way. If you didn't see the scale factor here, how did we get from 3 to 1.5? It's half. So what is our scale factor between Big and Robbie? It's not 2, it's either 1/2 or 0.5. So if we take half of 5.4, we get 2.7. Okay? So again, multiple ways to get there, depending on how much actual math you know. But if worse comes to worse, you can always do the calculations. All right, number 3. Sides of a large rectangle measure 900 feet by 9,600 inches. Approximately how many yards would the sidewalk need to be if it was installed across the field from one corner to the opposite diagonal corner? Okay. So we have a rectangle. Says it's 600 feet by 9,600 inches. Okay? We want to know what is the diagonal, so how would we draw the diagonal here? Goes from one corner to the other. And what kind of shape have we made? What kind of triangle? A right triangle. So if we're solving for the missing side of a right triangle, okay.
This is my favorite side. Since you're getting 7, couldn't you just do A plus B plus C?
No. That doesn't work that way. If it worked that way, we wouldn't do all the mess with the squares. Okay? We can't go directly into this formula. What's the problem with the numbers they give us? It's not that they're too big.
They need to be yards.
They're different units. Okay? So can we turn this 96 inches into feet? How? 9,600 divided by 12 is indeed 800. Oops. All right. Now, we could turn that into yards from here. But if we remember the one right triangle that we told you to remember because we said it would show up all the time,
12, 15.
we said it was always in what ratio?
6, 4, 5.
Not 6, 4.
3, 4, 5.
3, 4, and 5. Remember we talked endlessly about triangles that had a ratio of 3, 4, and 5. So now this one says 600 and 800. But if we simplified 600 and 800, what would we get?
3 and then
Well, even simpler than that. If we divide them both by 100, we'd get 6 and 8. Is 6 and 8 the same ratio as 3 and 4?
Yeah.
Which means our long side should be 10. Because 6, 8. No, not. Because this is, 6 is the same as 3 times 2. This is 4. So the 3, 4, 5 is the ratio, and then we can multiply it by whatever we need. So if we can multiply all these by the same number, it fits the same scale. Which means if this is 600 and 800, that means our long side should be 1,000. So that's 1,000 feet. And then we can turn into yards. So we can take 1,000 and divide it by. So 1,000 divided by 3 is 300 and. What are we going to notice here? This is just going to keep repeating. So we can't put the bar until we get to the decimal point. So it'll be 333 feet. Okay? So here's our answer. Now we could have turned this into yards first, and that's normally what I would tell you to do. But if we did that, then this ratio of 3, 4, and 5 wouldn't work quite as well because we'd have decimals. And since we don't want to mess with decimals, we don't do it till the very end. Okay, but right triangles you do need to know. You do need to recognize that any rectangle, if it says any problem about a rectangle and a diagonal, you can almost be sure that's what you're going to be doing.
Now, for
Yes. It would have been the same thing. Because remember, A and B, the two legs are interchangeable. All right, number 4. Cube has side length 36 inches. What is the area of the base? So if it's a cube, what shape is the base?
Square.
It's a square. If we're doing this in inches, it'd be 36 by...
36.
So what is 36 times 36? 1,296. Then it says to put that into square feet. So the problem is that some people are going to say, well, let's take this answer, 1,296, and divide it by 12.
Oh, why wouldn't that work?
Will that work?
Yes.
Well, let's see. If you divide that by 12, you get
108.
108. So let's keep this in mind. Don't write it down yet, though. And then let's actually figure out what would the side lengths be. So if it was 36 inches by 36 inches, what is that in feet? That is 3 feet by 3 feet. Okay, what is the area of a square that's 3 by 3? 9. Okay.
Oh, I get it.
36
You have to do the side lengths first.
And we've talked about this. This is really a scale factor question. What is the scale factor between 3 and 36? 12. But if we're talking about area, how is the area going to change? Does it change by a factor of 12? Remember we said that, that the new is equal to the original times scale factor. Why is it squared? Because it's area. So it's not just times 12, it would be times 12 squared. So we could, this idea you had of taking 1,296 and dividing it would work, but you wouldn't divide it by 12, you would have to divide it by, not 24, 12 squared. So if you divided 1,296 by 144, you know what you'd get? You'd get 9. I wouldn't really recommend that because this is that's a lot easier. Okay, the same thing's going to happen to yards. So please don't say you can just take 9 and divide it by 3. Okay, good. So if it's 3 feet by 3 feet, what would that be in yards? That'd be 1 by 1. You can't have a 0 by 0 square. 3 divided by 3 is? 3 divided by 3 is? Okay, that's it. No, there's 1 left. And then 1 times 1 is? 1. Okay? And again, we can use this formula here because what is the scale factor to get from 1 to 3? Our scale factor would be 3, so our area is going to change by 3 squared. So what's 1 times 9? 9. Hooray, it works. Well, the area of the base, because we're saying in all 3 of these examples, we're actually talking about a cube. But what shape is the base on a cube? Is the square. So even though it's talking about a cube, all we care about is the one side of it, or one face of it.
How would you know if it's a scale factor question?
I mean, in reality, does this have to be a scale factor question? Could we have solved this without ever using the word scale factor? Yes. I'm just showing you that, just like the rest of them, there's always more than one way to solve it. There's like a fancy way that'll get it quickly if you know what you're doing, and then a somewhat slower way, but will work and usually involves drawing pictures. Okay? So if you need to draw pictures, then by all means, draw pictures.
Mr. Ross, why is your square
I don't know. All right, blueprint shows a house length is 100 centimeters and the width is 80 centimeters. The actual house is 40 meters. What is the actual width? So again, we're dealing with shapes. So what should be the first thing we do? So the house's length. Okay, so I guess we're talking about the outside of a house. So it's got some windows.
Oh, it's a blueprint. Yeah, it's a model house.
It's got-
That looks like a prison.
okay, yes, it's a prison house.
Fix the other window.
Big house, I guess.
Okay, so it says it's 100 centimeters by 80 centimeters. And if the actual big house is 40 meters, so here's our actual.
Oh yeah, it looks scary. That's the manual. Make it look scary. That's for the Make the door look like it has a crown. Yeah. Like put like John Brown.
No, okay.
Wife's trying to do that house water down.
So, all right, here's where they're going to try to trick you, because it's going to say 40 meters, and you're immediately going to bound to be like, well, this one's 80. If I put 40 over here, this is going to be super easy, right? But 40 is the length, so that goes with this length, which is, so it's got to go on the bottom, okay? That's how adults, they're like, you know how we can get kids to miss this easy problem? Just that simple. We make it seem even easier.
Because they're jerks.
Because if you get smart enough, you might take their job.
They're Lisa's parents.
The same reason why TV wants to keep you watching TV. Because as soon as you get smart, you stop watching TV. So it benefits everyone. And
I used to watch TV a lot better. And Jeremiah still watches TV.
all right, we can discuss.
Can you do this like 100 minus 80 is 20, so that's 40 minus.
No, don't ever do that. Okay? All right, the question was, can we see the difference between the width and the length is 20? So does that mean the difference between this width and this length is going to be 20 as well? The answer is no, please don't ever do that because that makes me want to hit you. Okay? Okay, similar figures do not work that way. It is never a matter of adding and subtracting. It's always multiplying, okay? These are factors. So we take aside from the little, 100, okay? 100 goes with 40. And then another side from the little, 80 goes with x. Okay, we could cross multiply it just like this. Could we simplify 140 though? This would be, we could get 10 out of 4. We could also put 5 over 2. No, don't mess the other side. So then we have 2 times 80 is, so we have 160 divided by, so our missing width is, okay. Wait, what?
So it has nothing to do with 40,000 because 100
No.
centimeters to meters is 100 equals 1 meter.
That's the other question. Does the fact that we have different scales on these two, could we have converted this to centimeters? Yes, we could have, but we would have gotten the exact same answer. Okay? So if you're doing scale factor, you don't have to worry about converting it. Unless, of course, if this was 100 centimeters to 80 meters, then you'd have everything on the same picture has to be the same units, but across 2 different pictures doesn't matter as much. Okay? Not to say you couldn't. You could change it, get the same answer. All right, 6. Mr. Avocado collected student data. I called him Avocado. All right. So, so a scatter plot. We didn't really talk too much about scatter plots, but it's because they're not that difficult. We're comparing, what are we comparing? Shoe size and height, okay? When you talk about a scatter plot, you always think about what happens as one thing goes up. So as the shoe size goes up, what do we think happens to the height? If you imagine people with bigger shoes are probably people that are taller. So as shoe size goes up, height goes up. So if we needed to talk about what kind of correlation this would be, if they're both going up, we call this a positive correlation. Okay, just positive. I guess we can put the word correlation.
So if the height went down, it would be a negative correlation?
I'm not giving you that. It'll tell you that word.
Oh, okay.
Okay.
Oh, so it's a positive.
So if both things go up together, it's positive correlation.
If one goes down.
Now, if we took an example like hours on okay, if we think about as your hours in Black Ops increases, what will generally happen to your grades? Grades. So we'd say this would have a negative correlation.
Mr. Ellis, we have 3 or 4 left.
All right, so you've got 4 to take tonight.